Okay, this week we're going to talk about planetary circulations. So, we've talked about temperature, we've talked about moisture, pressures, winds. We're going to put them all together. And we're going to take a look at the world weather. The idea here is to focus on overall broad pictures. We're not looking at, West Virginia's weather is going to be rainy today, or there's a cold front passing through the middle of the United States. We're focused on, there's a bunch of lows across this latitude. There's big highs across this latitude. So we're going to look at a large sample, shall we say. So there's basic global circulation that says around the poles, we tend to have low pressure in the upper levels and actually high pressure towards the surface. Around 60 degrees north is an area of low pressure. Well, let's take a look at that. Right along about here is 60 degrees north. Guess what? There's a heck of a lot of low pressures along that latitude, isn't there? Around 30 degrees north tends to be high pressure. Yeah, here's about 30 degrees north. Oh yeah, look at that. High, 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 high. So we are in the battleground in between where we go fluctuate from high pressure to low pressure. Now, another thing about this is we are now beginning to move towards summer. So, what does that mean? Well, in the northern hemisphere, it means that as what would typically be the low pressure at 60 degrees north might lift a little further to the north. And that high pressure at 30 degrees is going to begin to move further north as well. So these are almost very stable circulations. You think about that high along 30 degrees north. And if you look back to the sailing days when Columbus came over or different other ships came across from Europe, the area they tried to go to was the south of that high. So the flow, look at it, it's clockwise. It would be from the east going towards the west. It would move them very nicely across the Atlantic. They didn't want to get stuck in that high pressure because there's not much wind there. To the north of the high, we'd have more west winds. So you can see how the high is kind of influenced where ships sail in the olden days. Now, further north, we have a lot of low pressure. Most people don't like to travel too far north in that lows, even in the wintertime. When ships are going across from Europe to the United States now, they tend to take a more southern route if possible, just to avoid all the stormy weather and stuff. Even though it's more direct, they'll try to take it if they can help themselves and get there quicker, but they do look at the overall weather. And along the equator is an intertropical convergence zone. What's that? It's an area of low pressure, and it basically follows the sun. So, in the our summertime, it is going to be north of the equator. Our wintertime, it's going to be south of the equator. Along it is the most intense heating. We have the most unstable air. Lots of thunderstorms develop. We have convergence. We have trade winds south of this high, and there's also everything mirrors themselves on the southern hemisphere. So we have trade winds there as well, and they converge right along the intertropical convergence zone. So now you have where that is going to be. Oh yeah, and interestingly, during the summertime, the oceans, yes, they warm. But think about it. Desert over here, lots of ocean out here, but then there's more land masses over here. Where the land is going to heat faster. We wind up with the intertropical convergence zone moving to the north. So now you have the whole picture of global circulations. Next week, we're going to talk about mid-latitude. We're going to focus more on home. But right now, we're just looking at a global picture here. saying, oh, gee, the United States kind of gets some of the lows from the north and some of the highs from the south. If you lived, think about it, there are wind shifts that are going to occur throughout the year because these highs move north or move south, or low moves north or south. With that, you're going to wind up with some interesting monsoon weather. Monsoons basically mean wind is coming from the same direction for at least a month or two. And we have a monsoon in the United States, for example. The monsoon develops over the desert southwest, New Mexico, Arizona, that area. All because everything has shifted to the north. That area begins to get heated. It develops a circulation off the Gulf of Mexico and off the Pacific into that area. And we wind up with a steady flow of wind into that area for months at a time. And that can move north into the Arizona, New Mexico, or maybe stay just south in Mexico. And that fluctuation causes a significant amount. Most of the precip that occurs in the southern parts of New Mexico and Arizona comes from that. So with that, let's move on. I wanted to look at a polar circulation. We're looking at the North Pole right now. And this is the jet stream. What do you see? Well, I see a big low out here, this part. Low pressure day. Oh yeah, really good size low here. Nice high. Another low down over here. Another high. So what you're seeing is what's called Rossby waves. They're very long waves. There's usually anywhere from 3 to 5 or 6 around the globe. When you're looking down at the North Pole, it's the easiest place to spot these. What happens is, where they develop, they don't tend to move real fast, and they will tend to pull in air from the Arctic or bring air up from the south, and they tend to have the most intense lows develop along them. Very strong highs tend to develop along one side of them. So this actually is Canada in here. We have a very large high in the western part of Canada, a very strong low on a Rossby wave coming into the United States now, developing there. So this is going to become a pattern where we wind up with lower pressure tending to be aloft over the eastern half of the United States. What does that mean? Well, you're bringing down cold air from Canada. Temperatures will average below normal. So let's just bring this down to a little lower latitude, down closer to us. And here's that high coming up into Canada, low pressure here. The developing Rossby wave in this area. A little bit of a low here. Oh yeah, we're in El Nino yet. What does El Nino do? It creates a very strong southern jet stream in the wintertime. That southern wet jet stream has been very strong this winter. Brought lots of precipitation to Southern California and across the Gulf Coast and some up the eastern United States. It also has prevented a lot of cold air from coming down from Canada. So you wind up with less cold air this time of year than you normally would. Now, there are breaks in this, and right now we're coming into one where that Rossby wave is going to develop. It's going to allow some cold air down from Canada. So we're going to be getting into a colder pattern for a while. Also, you can notice there's very strong segments to these jets. Notice, over New England, the Great Lakes, if you're flying, there's 150, almost 200 knot jet right here. So think about it. If I wanted to go from Detroit, Michigan, to Boston, if I can get up into the 30 to 40,000 foot range, I'm going to haul across there because of that jet. Aircraft like to find these jets because they can move them fast, very quickly, from one large area to another. However, they can cause some bumpy flights. And we're going to look that when you look at a jet streak like this, you have a left front, right front, left rear, right where. We talked about divergence a little bit this past week. Well, divergence is huge in developing low pressure. The left front quadrant has good divergence, and the right rear quadrant has good divergence. So along this jet stream, you have good divergence here and good divergence here. So if you were looking for low pressures to develop, they would be the areas you'd be focused on. Now, another part of climate and overall general circulations is the ENSO, El Nino, or La Nina. We've been in El Nino all winter long. El Nino 3.4 is typically what we use. It's an area in the middle of the Pacific. This has been the anomaly temperatures, over 2 degrees Celsius above normal, which is very, very significant. This was a major El Nino. However, notice, since November and December, it's now begun to settle and come down a little bit. That is the trend. And you go further out to the west, much coming down even more, almost down to normal, as a matter of fact. All that is propagating through the ocean out there in the Pacific. So that with time, you're finding these temperatures keep going down. And finally, this is the forecast. Notice that reality had, close to 2 degrees. But notice we're going into, by summer, an El Nino pattern where the anomalies are below normal. What does that mean? Well, it means that the jet that has been the strong southern jet won't be dominating as much. We'll tend to have more northern jet streams that'll be coming in and waves. So we're more typical of our winter times. So let's go through a little bit of what the PowerPoint that I got with this. So we're going to kind of go through this pretty quickly. But I wanted to give you just an overview of some things here. And we're going to think about it. The reason we have those things, all the different places, the circulations, are because the Earth, it rotates. If the Earth didn't rotate, what you would have is one side of the Earth would be hot all the time. In the middle of that, where the most direct sunlight would be coming in, that would be where the rising air is. And on the dark side, where the coldest air is, would be the opposite of that. So you would wind up two big circulations. Doesn't happen because we rotate. And we rotate around the sun as well. So because of that, what you wind up with is these areas, like I showed you on the map. Low pressure near 60 degrees north. High pressure near 30 degrees north. Low pressure again near the equator. And just the flip in the southern. And we looked at that from a planetary circulation perspective, and we noticed that it moved north in the summer, our summer, and south in our winter. So, high pressure, subtropical high, anticyclones. Interestingly, they occur on the west side of the United States, on the east side of the United States. On the west side of the United States, you're actually getting compressional warming on that side because it's the eastern side of the high. You wind up with most major deserts located on the eastern flank of these subtropical anticyclones. On the other side, however, you wind up with moisture coming up. You wind up with more heating, lifting, much more precipitation. So that is why down, for example, when you look at Florida, Georgia, the Carolinas, we get lots of precip in the summertime because that is subtropical high is beginning to dominate. If you go out to the west, what do you find in the summertime? The high begins to dominate. Very dry conditions in San Diego, Los Angeles, up along the west coast there. So these subtropical highs have a major influence on global climate, weather. We talk about the Icelandic lows, polar fronts along these highs and lows. There's the polar vortex, which increases strength or decreases strength. When it's very strong, cold air can't get out of up there, so they tend to keep the cold air around the Arctic. When it gets very weaker, kind of waves a little bit, and some of the cold air slips down to the United States. And here you can see the wavy pattern that we have typically across the United States. A low, a ridge, a low. And it varies on where those are. The tropopause will vary as well. Why does it vary? Well, you think about the tropics. You're getting almost all direct sunlight all the time. They're getting pretty hot. Very warm, less dense air pushes the tropopause higher. Go to the north, up by the pole, what do you get? It's a doggone cold. Condensed the air, packed it down tighter, tropopause is lower. In between where we live, we wind up with the tropopause varying because you wind up getting a very strong cold front, maybe, with strong upper level support, very low heights in the upper levels, pushes the tropopause low. Or you may have a nice ridge build over top of you, pushes the tropopause higher. There's a trade wind inversion. That is what keeps Hawaii from getting tremendous amount of thunderstorms. It actually causes it to get showers, but it doesn't let it get very, very unstable. It's an area, literally a stable air that's there above the oceans. And I mentioned about the ITCZ moving along. So, for example, if the ITC moves north in the summertime, this is a classic example of a monsoon that develops across India. We know that they get tremendous amount of rainfall in the summertime. Well, look at it. The winds are coming out of the south. The intertropical convergence zones move to the north. You wind up getting tremendous rain from all the moisture. We talked about the San Diego and the climate on each side of these subtropical highs. Interestingly, these highs are so permanent, and the lows as well, you wind up getting ocean circulations that mirror them. So, the North Atlantic gyre mirrors the subtropical high that's here. Guess what? That's the Gulf Stream coming right up and around it and eventually moving up into here. There's a North Pacific gyre. Guess what? The California current bringing cold water down along the west coast. All because of that subtropical high. Mentioned about the North American monsoon. And I told you Rossby waves here. Zonal flow. Basically, there's a wave, but not a very big wave across the area. You see this, we saw this several times in the wintertime, where the flow would be moving quickly. It's fairly fast, but it doesn't have a lot of wave to it. When you get a very strong wave, where you have really a lot of air coming out of Canada and a lot of air coming up from the Gulf of Mexico, you're creating a tremendous temperature contrast. You're going to get your most intense lows, your strongest fronts. And sometimes we get blocks. And depends on where you are in the block as to whether you're going to like it or not. If the block is such that you're on the warm side of it with good weather, hey, you might say, this is wonderful. I like to be here for a while. If you're on the other side where you keep having cold fronts come through, rain all the time, maybe flooding even, I don't think you're going to enjoy it as much. And this has happened, some of the classic one was 1993. Midwest got tremendous rainfall. It just sat there for months, all because of a blocked pattern. All right, jet streams always develop high in the atmosphere. Why is that? Well, because that's where the slope is the greatest. And that is, think about it, right there is where you're transitioning to the tropopause, where the actual temperatures are going to warm. So you wind up at the extreme temperature gradient across there. With that temperature gradient, you're creating a pressure gradient at that level, and that's causing these very fast winds. So we have the seasonal shifts. Sometimes in the summertime, you may get the jet stream basically across Canada, may even be out of the entire United States sometimes. Wintertime, it can go drop all the way down into Mexico. And here you see the short waves that tend to intensify in the middle of Rossby waves and then moving out, get weaker as they go over top of the Rossby wave ridge and intensify again in the next one. We're going to get a lot into cyclone development next week, basically just showing you divergence, convergence, and here's where I talked about that with the jets. We mentioned El Nino and La Nina, and how from a historical perspective they kind of flip-flop back and forth. It's interesting, there's hardly ever a neutral condition, almost always one or the other. All right, Ekman's spiral. It's based, again, off of forces. And the classic one for me has always been along the outer banks of North Carolina. I don't go down there a lot, but I have some friends that do. And they talk about going out one day and have 80-degree water, and the next day having 50-degree water. Well, what happened? All right, you have a wind coming from the south. That means you're pulling the water from the south to the north, typically, right? Ekman's spiral says, oh, Coriolis effect. Coriolis effect is deflecting that water to the right. And as you go down, it's deflecting it more. So it's gradually turning all the way around so that the lowest levels down by the bottom of the water are literally pushing into the land, coming up and replacing that nice warm water you had the day before. This is why you wind up with it very cold the next day. So when you have prolonged southwest winds along the eastern United States coast, you wind up with the Ekman spiral occurring and you get cold air, cold water upwelling. So fly through these a little bit. El Nino. There's a North Atlantic oscillation. What is it? It looks at the variations in air pressure between the subtropical high down over the Azores and the subpolar low over Iceland. And it has a major influence over the eastern United States as far as air temperature and precipitation. So when you have a positive index, you can expect stronger than usual winds blowing across Canada. Cold air masses are entering. Negative, more steering winds from the southward. Changes up. So you can see it right here on the impacts it has to the United States. Looking at this is key. A lot of times it's very difficult to forecast, but can hang positive or negative for a week or two at a time in the winter. The Arctic oscillation, all that is, we talk about an Arctic low over the center of the North Pole in the wintertime especially. If its AO is very, very high, that means there's a very intense low there. You aren't going to get a lot of cold air coming out of it. The AO, as it gets lower, you have more fluctuation, and the lower, the better chance of getting some very cold air moving into the United States. And there's a Pacific one as well, and their influence is also on different parts of the United States. Madden-Julian oscillation. What that is a area of thunderstorms that develops basically over the Indian Ocean. And it kind of traverses the globe over 30 to 60 days. There's a phase where it gets intense, and then there's a phase where it weakens. And it's almost like an up and down pressure pattern with it. And it can impact where storms develop in the United States as it's moving by and where they don't. It can impact where tropical cyclones will develop. So we watch the MJO, try to spot when it's occurring and what phase it's in so we can determine these kinds of impacts. So I know this was a lot to throw at you. So let me know whatever questions you have.